Hello everyone. Today I would like to give you an introduction to the steps used in the scientific method, as you can see from the title of this PowerPoint here. And if we look at the scientific method, you can see that it is an ordered series of steps that you go through with a few little forks in the road. And so if we take a look at our first slide here, what we can see is that scientific method really involves you making an observation about something. And the example I have here is somebody is making an observation that their flashlight does not work. And typically when we're looking at an observation, you're using your sensory apparatus. So you are looking at something, you're smelling something. These are not things where you're drawing a conclusion. It's an observation where you're looking and starting to think about it. And so those observations are going to lead you to ask a question. So again, if we look at this example, my flashlight doesn't work. And that's where you scratch your head and you say, I wonder what's wrong with my flashlight. And if we think about this scientific method, this is what scientists are doing all the time. They're looking at something and making an observation that is causing them to ask a question about what's going on with this. And if we go on to our next step in the scientific method, those questions that are based on your observation are going to lead you to what is known as a hypothesis. And when you look at a hypothesis, there's a lot of different kinds of ways that we can define this sort of thing. But a really basic and easy kind of way of defining a hypothesis is it's an idea that's on trial. We can put it in the terminology that I'm using here. It's really a proposed explanation for a set of observations. So you're explaining what you think is going on based on your observations there. So it really is an idea on trial. And when we look at our example here, my flashlight does not work, observation. Well, what's wrong with my flashlight? And you can think about this process here. I can come up with a variety of different ideas about what's going on with my flashlight there. And in this example, we're going to say the flashlight's batteries are dead. That is your idea that you're saying, I think this can answer my question right there. And a really good hypothesis often takes the form of if-then logic. And if you use that if-then logic, then you're making a prediction. And a good hypothesis means you can make a prediction so you don't have to wonder about the results. You're really looking at black versus white as opposed to shades of gray. So in our example here, the prediction, okay, my flashlight's batteries are dead. Well, what do you predict? If I replace the flashlights, or if I replace the batteries, then the flashlight will work. And so at the next step there, okay, now that you've made this hypothesis, you've got your idea on trial, what do? You perform an experiment. And so what do you do for this case? I replace the batteries with some new ones, and then I test it out. In this one, it's really simple. You push the button and check. Does my flashlight work? That is my experiment. Replacing the batteries and seeing if that actually answers the hypothesis. So we're looking at, do these results actually support this hypothesis here? And if we go on to think about this, and here you can see that fork in the road on the left side there. The experiment, I replaced the batteries with new ones, and look, the flashlight turns on. That answered the hypothesis. Yes, my hypothesis was supported based on the experimental results. And if you're doing this sort of hypothesis-driven science, you're going to be making more predictions based on the experimental results where your hypothesis is supported. And if you look on the right side here, okay, my initial hypothesis is not supported. And that's not good. That's not bad. It's just you guessed incorrectly about what could be an answer to your possible observation that's out there. So what do? You try again. You come up with another hypothesis. Here, okay, the batteries aren't the problem. Well, what else could be wrong with my flashlight? And I came up with one right there. The flashlight's bulb is not working. And what do you do with it? Now you've got a new hypothesis, and you run it through this series of steps here. You make your predictions. Okay, what would my prediction be? Flashlight's bulb isn't working. Replace the bulb, and then do the experiment. Test your flashlight and see whether or not it's working. Analyze the results. Either your hypothesis is supported or it's not supported. And if it's not supported, then you go on and you check another thing. Do hypothesis 3. And you can see how this chain of events continues to really feed on itself. And if you think about it, the experimental results that are coming out of this that are answering that hypothesis, that is really another observation that's going to lead you to ask more questions. And so this hypothesis-driven science model really does have a tendency to sort of feed on itself as you continue to ask more questions based on the observations as you learn more and more about what you're looking at. So hopefully you got a little something about that, and I want you to think about, okay, what else could be going on when I'm looking at hypothesis number 3 right here. Can you come up with another hypothesis for what could be going on with that flashlight, and think about what would my experiment be, how would I make those predictions, and whether or not it is supported or not supported there. Please let me know if you have any questions when we talk about this in class, because this is really a fundamental kind of methodology that we need to understand when we're looking at the scientific method. Thank you.